Okay, in this video we're going to talk about the polar form of a complex number and some of the arithmetic and the Moll's theorem that goes with it. Now, the main reason I'm talking about the polar form of a complex number is I use a shorthand notation that really speeds up the process quite a bit, and I want to show you that. You should know that the polar form of a complex number, z, which is sum of a plus bi, is equal to r times the cosine of theta plus I sine theta. The way I abbreviate this is RCIS theta, R cosine I sine theta, okay? And I abbreviate all of them about like that. Now, the first example we have z1 is going to be the negative square root of 2 times I. z2 is negative 3 minus 3 times the square root of 3 times I. And we're asked to find the polar form of these guys find these guys in polar form. Now, a picture's worth 1,000 words. Remember, if this is x, this is iy, we have a real axis and an imaginary axis. The negative square root of 2i is going to be down here somewhere. Okay, so we can say that z1 is going to be, now because it's just a complex number, the distance from here to here, r, is the square root of 2. So we can say that z1 is going to be the square root of 2 CIS 3 pi over 2, because this angle is 3 pi over 2. Now, for z2, I have negative 3 minus 3 square root of 3 times I. That puts me in the third quadrant, out here somewhere. So in this case, we do have to find an r and an angle. So z2, well, I want to write this as negative 3 times 1 plus the square root of 3 times I. And then we can say that r is the square root of negative 3 squared times 1 squared plus the square root of 3 squared. And that gives me the square root of 9 times 1 squared plus square root of 3 squared is 1 plus 3 is 4. And this turns into 3 times 2, or 6. So the length here is 6. Now, for theta, we can say that the tangent of theta, and keep in mind we know that we're in the third quadrant, tangent of theta is going to be b over a, so it's the square root of 3 over 1. And looking at the unit circle, the square root of 3 over 1 gives me theta equals 4 pi over 3 in the third quadrant. Okay, so I want to say that z2 is going to be 6 CIS 4 pi over 3. Okay? All right. Now, next, I want to talk about z1 times z2. And there, if you remember, de Moll's theorem says this is r1 times r2, and in my shorthand, CIS, theta 1 plus theta 2. Now, I should point out to you that the software WebAssign will not take this form, this CIS thing. You have to write out. Come back over here for a second, sorry. We'd have to type into the software z1, we'd have to write that as the square root of 2 times the quantity cosine 3 pi over 2 plus I sine 3 pi over 2. And by the way, in WebAssign, I don't know if y'all found this out yet or not, but whenever you're typing these in, after you hit, say, cosine, hit a space, and then type 3 pi, the letters pi, pi turns into pi. Then you can hit divide, hit 2. It's a whole lot easier to type these in. Okay? Now, z2 would be 6 times the cosine of 4 pi over 3 plus I sine 4 pi over 3. And those are the answers, the actual answers we'd have to type in WebAssign. Okay? Now, back to Z1 times Z2. All right, so we found R1 was square root of 2, R2 is 6, and then we're going to have CIS of theta 1, which is 3 pi over 2 plus theta 2, which is 4 pi over 3. Okay? And then this turns into 6 times the square root of 2, CIS. Don't forget you got a $100 calculator. It's really good at adding, subtracting fractions. I don't have that with me, so I got to do it the old-fashioned way. Least common denominator is 6. This is 9 pi. This is 8 pi. So we get 6 square root of 2 CIS of 17 pi over 6. Okay? Now, 17 pi over 6, there's some issues with that. Now, because 17 pi over 6 is bigger than 2 pi. If you think about it, 17 pi over 6 is the same thing as 2 and 5/6 times pi. And 2 pi gets us around the circle one time, so this turns into 6 square root of 2 CIS of 5 pi over 6. Okay? Now, another part of this problem, you're asked to find Z1 divided by Z2. Well, the theorem tells us this is R1 over R2, and then CIS of theta 1 minus theta 2. Okay? Now, this, for this particular example, R1 is still the square root of 2, R2 is 6, and then we have CIS of theta 1, 3 pi over 2 minus 4 pi over 3. And pick a bad day to run off without a calculator. Once again, we have square root of 2 over 6, CIS, least common denominator is still 6, multiply this, well, we're going to have 9 pi minus 8 pi. 9 pi minus 8 pi. And that turns into the square root of 2 over 6, cosine imaginary sign, 9 pi minus 8 pi is pi over 6. Okay? All right, and then one more problem in here. I'm double checking my answers to make sure I got right. The other thing I want to talk about is 1 over Z1 or 1 over Z2. We may do both of them. Now, 1 over Z1, well, the way I do this is I find the polar representation of 1. Now, if Z3 equals 1, the polar representation, well, if you think about it graphically, 1 puts you there. Your angle, or your magnitude is 1. Your angle will be CIS of 0 because you're at 0 degrees or 0 radians. So 1 over Z1 becomes R1, or let me write that. This is just going to be CIS of 0 over, now Z1 was square root of 2, CIS of 3 pi over 2. All right, and that turns into, well, probably should have written that out. But this turns into 1 over the square root of 2, and then I'm going to have CIS of 0 minus 3 pi over 2. Okay, now, here's the trick. Negative 3 pi over 2 means that we're measuring this way and puts you up here. In standard form, that becomes pi over 2. So what we get is 1 over the square root of 2 CIS of pi over 2. Just make sure you get your angles in standard position. Okay? All right, and let's go ahead and do 1 over Z2. 1 over Z2 will be 1 over R of C2 is 6. And that's going to be CIS of 0 minus Z2, 4 pi over 3. Okay. And this turns into 1/6 CIS of negative 4 pi over 3. Now, negative 4 pi over 3. We're lucky that we have special angles. Now, 4 pi over 3 in standard position puts me in the third quadrant, so negative puts me in the first quadrant. What we're saying is that's 4 pi over 3. No, it's not. That's incorrect. I hate making mistakes on video. All right, 4 pi over 3 is in the third quadrant in standard position. So I need to go 3 quadrants. So this is 4 pi over 3. The thing we want is that guy, and that's going to be 2 pi over 3. And 2 pi plus 4 pi gives me 6 pi over 3, so that gives me 2 pi, good. So this turns into 1/6 CIS of 2 pi over 3. Okay? So hopefully this helps a little bit. Good luck. Go do some math.